This video is for Math 95, and this is for the sample test. So I'm just going to take the test and go over the problems, and if you have any questions about them, please let me know. So question 1, we start out with an absolute value equation. Absolute value 3s plus 6 equals 12. So the fundamental idea of an absolute value equation is that it has two pieces. Okay, one piece says 3s plus 6 could be 12, and the other one says 3s plus 6 could be negative 12, because both 12 and negative 12 have an absolute value equal to 12. So now we have to solve each of these. 3s is 6, s equals 2, and over here 3s is negative 18, and so s equals negative 6. So we get two solutions for the absolute value. S could be 2 or s could be negative 6. Problem 2 is absolute value inequality. And we approach it in a similar way, but it starts out more complicated than problem 1 does, because to work with an absolute value, it's usually best to isolate it first and then split it into two pieces. So to isolate this absolute value, I'm going to add 7 to both sides, and then divide on both sides by 3. So now I've got absolute value 2x plus 1 greater than 4, and I can split it into two pieces. So 2x plus 1 could be greater than 4, 2x plus 1. And now when I make this negative 4, this flips around and become less than. Okay? So again, get the x by itself, and here, divided by 2, we get x greater than 1.5, and over here we would get x less than negative 2.5. And so then we want to graph this on a number line. Put your 0 in there, 1.5, negative 2.5. This one goes off in this direction, and that one goes off in that direction. Okay, let's see. All right, number 3. This is a compound inequality here. We've got 4 less than 5x minus 8 less than or equal to 17. I talked about this when we covered this topic. There are now, instead of just 2 places, like where you have to subtract 1 in 2 different places, here there's 3 different places where I'm going to add 8. Here, here, and here. That keeps all 3 parts of this inequality in balance with each other. So these cancel out. This will be 12. And over here, 25. And so then all we have to do is divide, again, in all 3 places by 5. So we get x less than or equal to 5, but greater than, looks like 2.4 there. And then we want to put this on the number line. So this one gets shaded in. That's an open circle. And we want all those numbers in between them. Okay. Let's see here. I think these markers are smearing a little bit. We'll try to clean them up in between the problems. Okay, so that was number 3. Now we've got 4, 5, 6, and 7. These are all factoring problems. So let's just take them one by one. Problem 4 is a pretty straightforward trinomial factoring problem here. Got x squared plus 10x plus 25. And so in this type of factoring, we need factors of 25 that add up to make 10. And so in this case, that would be x plus 5 times x plus 5. If you want to write that x plus 5 parentheses squared, that's fine too. But either way is correct. Let's see here. Problem 5 is also a trinomial factoring problem. This one's a little bit trickier though because we've got a leading coefficient. That 3x squared makes this significantly more difficult to factor than number 4. But the fact that 3 is a prime means that it can only split up one way. 3 times 1. Now with the 20, we've got a bunch of different possibilities. You can have 1 times 20, you can have 2 times 10, you can have 4 times 5. These are more common than these, unless this middle number is really big, but these smaller factor pairs are typically more common. So let's see. If I put, we're looking for these two multiplications to have a difference of 4. So let's see, if I go 5 here and 4 here, that's 15 minus 4 is 11. That's no good. This is 12 minus 5 would be 7. Also no good. So this one is not going to be the one that we're going to use. Let's see. If I put the 10 here, that would make 30. That would be too much. Let's put the 10 here and the 2 here. Now this is 6. This is 10. 10 minus 6 is 4. Okay, that's what we want. We need a negative 4, so the 10 should be negative. The 6 should be positive. And there's our factorization. Okay, problem 6 also has 3 terms, but in this one it looks like you've got a common factor that you should factor out first. Before you try to split this up into binomials. So we've got a common factor of 2 in the coefficients and x in the variables. So what's going to be left here? We're going to have 1x squared plus 14x plus 49. And this is actually very similar to that problem that we just saw number 4, because this is a perfect square, and then this is 7 plus 7. And so this is going to split up as x plus 7 times x plus 7. You can write that x plus 7 parentheses squared. Like I said on that last problem, either way is correct. Okay. Now this last one in the factoring section, notice that it has 4 terms, whereas these trinomials that we've been looking at only have 3 terms. And that's an indication that this is going to be a different kind of factoring. This is going to be a factoring by grouping problem. So, problem 7, we start out x cubed plus 3x squared minus 6x minus 18. And to do the factoring by grouping, we want to split this into the front 2 and the back 2. Here in the front 2, factor out an x squared, and that'll leave you with x plus 3. And in the back 2, factor out a negative 6. That'll also leave you with x plus 3. That's not a 16. There we go. Okay. Now we factor out the x plus 3, and what's left here, x squared minus 6. And there we go. So as long as you recognize the problem and are able to do that factoring in the front and the back, that problem is not too bad. Okay. Let's see what else we've got here. Oh, now we've got the section with the rules of exponents. Let's see here. So 6 x squared y to the 7th, and then 3x over x squared y to the minus 4 to the minus 3 power. Okay. Well, I'm going to leave this part alone because there's not much that I can do with that until this one gets simplified a little bit. So first, let's move that y to the 4th to the top, and then I'll also cancel out that x with that x, and so we end up with 3y to the 4th over x to the negative 3 power. So, if I flip that over, then we'll have x over 3y to the 4th to the 3rd power. Don't forget we've still got this negative 6 x squared y to the 7th over here. And so then this will get x to the 3rd over 27 y to the 12th. This is over 1, and then we can do some canceling. Let's see, this cancels out 7 of these, leaves you with y to the 5th. 3 goes in here negative 2 times, 3 goes in there 9 times, so we come out of this with negative 2, x to the 5th on top, 9, y to the 5th on the bottom. Okay. The next problem is a square root or radical expression that we want to simplify. And the way to do that is to find the perfect squares and pull them out from the square root. So let's see how that's going to work. Problem 9. We've got the square root of 48 x to the 13th y to the 5th. So 48 is divisible by 4. I mean, if you're looking for perfect squares, you're going to have 1, 4, 9, 16, 25, and so on. So this is divisible by 4. It's also divisible by 16. Okay? This is 16 times 3. So I'm going to make 2 square roots, one for the perfect squares and one for the things that are not perfect squares. So remember, any exponent, any variable raised to an even numbered exponent is a perfect square. We'll have one of each left over. Now we can square root this. This will be 4x to the 6th y squared, and left inside the square root there is 3xy. Okay. And then I think next comes the problem where we want to express a square root using exponents. All right, let's see here. So, yeah, problem 10. Problem 10, this one's pretty straightforward. It is the cube root of a to the 11th and b to the 4th. And so we just want to write this with exponents, a to the 11 over 3, b to the 4 over 3, and we're done. There's not a whole lot of work in that. That's really just a problem about do you understand how to move back and forth between those different notations. All right, problem 11, we want to add and subtract these complex numbers, 8 plus 5i, plus 2 minus I, and then subtract 3 plus 11i. So let's take the parentheses off. These will stay the way that they are, but here we'll get minus 3 minus 11i. And then we can just put together all the real parts and all the complex parts. So that'll be 10 minus 3 is 7, 5i minus 1 is 4i, minus 11i is negative 7i. Okay, in problem 12, we want to multiply these two complex numbers together. Let's see here, 4 plus I times 7 minus 3i. Okay, So if we distribute here, we'll get 28 minus 12i plus 7i minus 3i squared. So we're going to put those two i's together. The minus 12i, the plus 7i makes minus 5i. And here I squared is negative 1. And so this becomes a positive 3. 28 minus 5i plus 3. And so we end up with 31 minus 5i. All right. Now we get into the quadratic formula problems. Although I think this first one we don't need the quadratic formula for. But we do need to square both sides. So let's see here. Yeah. Problem 13. Negative 5 plus the square root of 4x minus 1 equals negative 2. All right, so the idea here is that we want to get the square root by itself. So let's add the 5 over to the other side. Square root 4x minus 1 equals positive 3. And then we'll come in and square both sides. And that'll bring out that 4x minus 1 from under the square root. And we'll end up with 4x minus 1 equals 9. And then get the x by itself. 4x equals 10. X equals 2.5. Okay, let's see here. So that was 13. Now we get into the problems with the quadratic formula. So problem 14 is in standard notation. There's nothing that you need to do there. So 14, x squared minus 3x plus 5 equals 0. Let's see here. I'm going to turn on the projector for one of the upcoming problems. I'm going to let this warm up so that it'll be ready when I need it. All right, so here we just need to use the quadratic formula. Okay, you'll have the formula given to you on the test. So negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so a is 1, b is negative 3, c is positive 5. So negative 3 plus or minus the square root of negative 3 squared minus 4 times 1 times 5 all over 2 times 1. Okay, that projector's coming on. I'll turn it off as soon as I can. There we go. Okay. Let's see here. So we need to get back to calculating. This will be a positive 3 plus or minus the square root of 9 minus 20 all over 2. So 3 plus or minus the square root of negative 11 over 2. So now that you've got the negative under the square root, your answers are going to be complex. So that means we need to split this fraction into 2 pieces. 3 over 2 plus or minus I square root 11 over 2. Okay? So there's an exact value for our answers. And then I can also approximate this by doing the square root of 11 and dividing it by 2. And then we'll get 3 halves plus or minus 1.658 times I. Okay? All right, let's see here. Now 15, there's a little bit more work involved because it's not in standard form. And so I'm going to erase all of this so I've got plenty of room. Okay, let's take a look at 15 here. So, in problem 15, we start out 2x minus 3 times x plus 2 equals x minus 3 all squared plus 5x. Okay, so first thing we need to do is simplify this down and put it into standard notation. Let's clean this up a little bit before we get started. Alright, so over here we'll get 2x squared plus 4x minus 3x, so that's plus 1x minus 6. This x minus 3 squared is x minus 3 times x minus 3. And so that'll be x squared minus 6x plus 9. So what we get here is 2x squared plus x minus 6 equals x squared minus x plus 9. Okay, I'm going to move everything over to this side. So subtract x squared, add x, and subtract 9. These all cancel out. This will be x squared plus 2x minus 15. You can run that through the quadratic formula if that is what you prefer to do. This is factorable, and it's pretty straightforward. X plus 5 times x minus 3 will give you x squared plus 2x minus 15. And so we get solutions of x equals 3 and x equals negative 5. And there we go. That's problem 15. But the key is you've got to put this into standard notation, into standard form, in order to solve it. All right, let's see here. Problem 16. We've got a toy rocket problem. Let's see, I think I've got enough room right here to do this one. So 16, we've got this equation, h is negative 4.9 t squared plus 24.5 t plus 6. Okay. So this describes the height of a rocket in meters, t seconds after being launched. What is the maximum height of the rocket? Around your answer to the nearest tenth of a meter. So the maximum height, so remember that the graph of one of these things is a parabola. Okay, if you put time down here and height over here, typically you're going to get something that looks like this. The highest point is the vertex of the parabola. Okay, that's the way this is set up. And remember that your vertex, the x-coordinate is negative b over 2a. So negative 24.5 over 2 times negative 4.9. So let's see what we get out of this. 2.5. So after 2.5 seconds, that's where the rocket will be at its maximum height. But the problem is asking, what is the maximum height? It's not saying how long does it take to get there. So we've got to plug this 2.5 back into the equation and calculate what the height of this rocket is actually going to be. All right, so negative 4.9 times 2.5 squared plus 24.5 times 2.5 plus 6. And so if we want to round to the nearest tenth, we're getting 36.625. So if we want to round that, that would just be 36.6. Okay. Now problem 17. This is what I wanted the projector for. So, because we've got to do some graphing on a grid. Got to graph a parabola. And so again, we're going to be using that vertex formula. And then we'll find a couple of points on either side. Okay, let's see what we've got here. Whoa, that's a little too big. Okay, come on. Come on, technology. There we go. Okay. All right, so let me turn that off while I set the problem up, and then I'll turn it back on to make the graph. Okay, so what we need to graph here, problem 17, find the vertex and 4 additional points. So our equation is y equals negative 3x squared plus 18x minus 20. So our vertex, the x coordinate is going to be negative b over 2a, which is positive 3. Okay, well that's good to know. So now we can make a table of values for x and y. 3 is going to be the vertex, and I'll pick 2 points on either side. And because of the symmetry of the parabola, usually we only have to do 2 of these 4 calculations, right? I always check them out because just to make sure that they match up. All right, so in this problem, this will be negative 3 times 3 squared plus 18 times 3 minus 20. So negative 27 plus 54 minus 20. That should be 7. Yeah, that's what it looks like to me. But it's always good to double check when you're working on these. Okay, positive 7. Good. All right, so let's see. 2, we're going to have negative 3 times 2 squared, 18 times 2 minus 20. So let's see here, what do we get? Negative 12 plus 36 minus 20, that should be 4. Now this one should also be 4. Let's see what we get here. 4 squared, 18 times 4 minus 20. So that's going to be negative 48 plus 72 minus 20. Yeah, that's 4. Good. For 1, negative 3 times 1 squared, 18 times 1 minus 20. So what is that? Negative 23 plus 18. So that should be negative 5. And I'll check this one down here to see if this is negative 5 as well. 18 times 5 minus 20. So negative 75 plus 90 minus 20. Yeah, negative 5. Okay, so this is where my graph is going to go. So let me actually move all of those y coordinates over a little bit so that I'll have room. So negative 5, positive 4, positive 7, positive 4, and negative 5. All right, there we go. Now let's bring that grid back up. And notice that on the test paper it does say you really need to graph on the grid and draw the x and y axes. So here's the grid. This one already has x and y axes. On your test paper you just need to draw those and make sure to indicate your scale. And now we can graph these points. The point 3, 7 is right here, and then 2, 4, and 4, 4. And then 1, negative 5, and 5, negative 5. So this is kind of a skinny parabola. And it looks something like that. Okay, so that's problem 17. Let's see here. All right, so now we've got this last batch of problems from the chapter on rational expressions and equations. And so we'll work through those. Okay, problem 18. So this is just a simplifying problem. So we want to factor the top, factor the bottom, and cancel out any common factors. So the top factors is x plus 3 times x minus 3. The bottom factor is x plus 3, x plus 1. These are common factors, and we're left with x minus 3 on the top, x plus 1 on the bottom. Okay. Problem 19 is a division problem. So this is x squared plus 5x over x minus 2. And let's see, divided by x squared minus 7x over x squared minus 9x plus 14. So the first thing I'm going to do is to rewrite this as a multiplication by the reciprocal. So let's look at each of these expressions and think about how we want to factor them. Notice that this is the only one that has 3 terms, x squared minus 9x plus 14. So that's going to factor, that's going to split up into 2 binomials. And it's pretty straightforward. 7 times 2 is 14, 7 plus 2 makes a 9, but we need them both to be negative to make that negative 9. Okay, good. These two don't have a constant term, which means that they have a common factor of x, and you can just factor out that x. And here you'll be left with x plus 5. Here you'll be left with x minus 7. X minus 2 is prime. It can't be factored. And so it'll just cancel that one. The x minus 7's cancel. The x's cancel each other out. Let's see, nothing left on the bottom, so all we get is x plus 5. If you want to write it x plus 5 over 1, that's fine too. Okay. Problem 20. This one will be a subtraction problem. So, x over x minus 8 minus 3 over x. Now notice that this is not an equation. Same thing with problem 19, not an equation. I mean, I put an equal sign in here because these two are equal to each other, but the thing started out without an equal sign. Okay, so we're not solving for anything here, we're not solving for anything here. Problem 21, we'll see an equation. Alright, so we need to make a common denominator, which will be the product of these two denominators. So this one gets multiplied by x over x. This one gets multiplied by x minus 8 over x minus 8. So let's see here. This will be x squared over x times x minus 8 minus 3 times x minus 8 over x times x minus 8. And then if we subtract them, they'll just have one denominator there. And then we want to simplify the top. So this will be x squared minus 3x plus 24 on top. Yep. And then x times x minus 8 on the bottom. I don't think the top is factorable. You've got 1 times 24, 2 times 12, 3 times 8, and 6 times 4. None of those add up to give you 3. Okay. So we just leave that the way that it is. And now we've got one more problem to work on. This is kind of a long, involved problem, so I'll erase this stuff and give myself plenty of room to work on this. Okay. So, problem 21. Start out x over x plus 2 plus 3 over x minus 4 equals 8 over x squared minus 2x minus 8. Okay. So, these two denominators are prime. They can't be factored. This one can be factored into the product of the other two. So this is our common denominator. We're going to leave this one alone, and we're going to turn each of these into this one by multiplying by the missing factors. So this one needs to get multiplied by x minus 4 over x minus 4. this one gets multiplied by x plus 2 over x plus 2. So what do we end up with here? On the top, we get x times x minus 4 plus 3 times x plus 2. And on the bottom, you've got x minus 4 times x plus 2 on both sides. And that's the point, is that you want these two denominators to match up so that you can then come in and multiply on both sides by that denominator and cancel them both out. And so what we're left with then is just x times x minus 4 plus 3 times x plus 2 equals 8. Not so bad. So let's distribute. That'll give us x squared minus 4x plus 3x plus 6 equals 8. Okay. X squared minus x plus 6 equals 8. Subtract the 8 over. X squared minus x minus 2 equals 0. Again, you can run this through the quadratic if you'd like to. I think it's a lot easier just to factor it. This will be x minus 2, and that'll be x plus 1. And so our solutions here are going to be x equals negative 1, and over here, x equals positive 2. Okay, so that's about what you're going to see on the test. Right? I always tell people you'll have the same number of questions, the same types of questions, just different questions. All right? If you have any questions while you're studying, please let me know. Otherwise, best of luck on the final exam.